In the last couple of lessons, I've really concentrated on doing the math with technology, and this lesson is going to be no different, but the concepts behind what's going on are different. In this case, we're going to compare two independent population proportions. We're no longer dealing with means, we're dealing with proportions. There should be some characteristics that are present when we're conducting this type of hypothesis test. Number one, they're two independent samples that are randomly chosen. Two, the number of successes is at least 5, and the number of failures is at least 5. If you remember when we were dealing with one sample, we had that little miniature test of n times p must be greater than or equal to 5, and n times q is greater than or equal to 5. This is right up the same train of thought. And then we want our population to be at least 10 to 20 times the size of our sample size. This keeps it from being overly sampled, kind of overly simplifying our population and causing incorrect results. Now let's get down to the meat of it and talk about the math. This might look super scary, but again, we have technology that will do this math for us, but I do suggest that you look this over and figure out what's going on here. I'm going to go through it very briefly. We have two samples, and the number of items that are in those samples, that's the NA and NB. The actual values itself are the XA and XB. The proportion is going to be you add up all your X's in your A category, add up all your X's in your B category, add those two things together, and then divide it by the total amount that you have. That's the pooled proportion. In essence, you're kind of taking the average of everything, not worrying about whose group is in what. Now, our distribution for the differences is our thought process that the probability of something happening in A minus the probability of something happening in B. We're going to assume the difference is 0, and then our standard deviation from the difference is this big equation of PC times 1 minus PC. That's just the probability. Think of it as P and Q. 1 minus P is Q. In this case, the C just represents that it's a pooled proportion. So P of C times 1 minus P of C, in other words, Q of C, times 1 over N of A plus 1 over N of B. That's going to be like our standard deviation of our differences. The test statistic is a z-score, and we're going to deal with P prime of A minus P prime of B minus P of A minus P of B, but this P of A minus P of B we're going to assume is 0. So that little portion kind of drops out all over this standard deviation, this standard error that's on the bottom. It is huge and complicated looking. It's not really when you start plugging in numbers, but it looks ugly. We are going to use technology to solve these things. So let's run through an example. Two types of medications for hives are being tested to determine if there is a difference in the proportion of adults' patients' reactions. 20 out of the random sample of 200 adults given the medication A still had hives 30 minutes after taking the medication. 12 out of another random sample of 300 adults given medication B still had the hives 30 minutes after taking the medication. Let's test this at a 1% level of significance. Now, I'm going to jump and do the web stuff first, so I'm going to jump over to a website, and I have shared this website in Canvas with you. It's using our social science statistics website, which is really cool. They have a ton of calculators there, but I really like this calculator under their heading. Here's the top part of the website. I just need to bring it down to where we can actually see what I'm plugging in. So I just wanted to see the top part of the page. And okay, here's what we need to do. All right, so let me put in my information that I need. So our proportion, think of it as the number of successes. So we have 20 out of a random sample of 200. So our sample successes is 20 out of 200. Our sample 2, we had 12 out of another 200. And we are at a significance level of 1. Now I do want to go back and I want to reread the question to make sure that I know if it's one-tailed or two-tailed. Two types of medication for hives are being tested to determine if there is a difference in the proportion. So difference meaning two tails, and then I'm going to calculate Z. And our result is our p-value is 0.14156. Because our alpha is 0.01, our p-value is greater than that, we fail to reject H0. And because we fail to reject H0, H0 is the two proportions are equal to one another. And therefore, our claim was, is there a difference? No, there's not a difference. At least the evidence suggests there's no difference. There's insufficient evidence to support that it's different. Now, I'm not going to repeat the same question as I did on the website in the TI-84. I'm going to actually do the try it. Two types of valves are being tested to determine if there is a difference in pressure tolerances. 15 out of a random sample of 100 of valve A cracked under 4,500 psi. 6 out of a random sample of 100 of valve B cracked under that 4,500 psi. Let's test it at 5% level of significance. So let me pop up the TI-84. All right, we need a z-test for proportion, and there are two samples. So let's run over to Stat, go over to our tests, go down to our 2 proportion z-test, number 6, oops. All right, our x1 was, we had 15 out of 100, so our x1 is 15 out of 100. Our x2 was 6 out of 100, 6 out of the 100. And we want to see if they are different, so it's going to be not equal to, and I'm going to go ahead this time because I have the TI-84 and draw the solution. Okay, we are testing it against a 5% level of significance, so 0.05. Our p-value is 0.03. Our p-value is smaller than our alpha, and therefore we have to reject H0. If we reject H0, H0 says that they are the same, then we have enough evidence to say that the two types of valves being tested to determine if there's a difference in pressure tolerances, we have enough evidence to support there is a difference in pressure tolerances. Okay, let's look at another example. A research study was conducted about gender differences in sexting. The researcher believes that the proportion of girls involved in sexting is less than the proportion of boys involved. The data collected in the spring of 2010 among random sample of middle and high school students in large school districts in southern United States is summarized in this table. Is the proportion of girls sending sexts less than the proportion of boys sexting? Let's do alpha at 1%, so 0.01. All right, I'm going to throw this into the calculator. I could use the website, but I'm going to go ahead and use the TI-84 for this one. And throw it up here. I'm going to go to my stat, tests, for my 2 proportion z-test. All right, so one was, we had a total of 156 girls out of 2169 For the boys, we had 183 out of the 2231. This is not an equal. We want to know if the girls are less than the boys. And I'm going to go ahead and draw this. All right, remember alpha is 0.01. Our p-value is 0.1045. That means our p is greater than our alpha. We cannot reject H0. We were testing to see if girls were sexting less than boys, but that's an HA. We do not have enough evidence to support that claim because we did not rule out that they are sexting greater than or equal than boys are. So all we can say is we do not have enough evidence to support our claim that girls are sexting less than boys are, the proportion. All right, so for example 1010, researchers conducted a study of smartphone use among adults. A cell phone company claimed that the smartphones are more popular with white, non-Hispanic than African Americans. The result of the survey indicate that 232 African American cell phone owners, randomly sampled, 5% have iPhones. Of the 1,343 white cell phone owners randomly sampled, 10% own iPhone. At 5% level of significance, is the proportion of white iPhone owners greater than the proportion of African American iPhone owners? Okay, so popping over to the website to do this particular problem, when I was practicing this, I really did run into a couple of issues on how this particular website wants us to put in the data. First and foremost, you can't put any percent. So even though the question says, hey, 5% have iPhones or 10% have iPhones, you can't put it in as percent. You also can't really do it as a math equation. So that leads us to just putting in a value, but it doesn't want a decimal. It doesn't want the true amount. So for example, African Americans were a total of 232. And for the white cell phone owners, that was 1,343. 10% of 1,343 is 134.3. But this decimal is going to cause problems, so I'm going to round it. So the numbers will be slightly off, but it will work. 134. And 5%, I haven't tried one thing. I am going to try to do a math equation here. I don't think it will work, but we'll see. Yeah, I get an error, so I can't do the math inside this particular calculator, so I'm going to round. If I did that calculation, it'd be 11.6, so I'm just going to round to 12. And it is a one-tailed test, not a two-tailed test. I'm going to hit calculate. And it looks like our p-value is 0.0099, and that is a lot less than our alpha, and therefore we would reject H0, meaning our claim that there's a greater difference in the proportion, we have enough evidence to support that. But let me show you what it's like on the TI-84. Okay, just like the website, for this particular test, your X values, you don't want decimals. So when you're doing the calculation, be sure your X1 and X2 are not decimals. I'm going to jump over to Stat, Tests, and down to number 6, Two Proportion Z-Test. My X1, I do want to cater this to the problem. The problem is asking, is the proportion of white iPhone owners greater than the proportion of African American iPhone owners? So I'm going to put in all the information for the white iPhone owners first. So X1 will be the 1,343 times 10%. Now, I am not going to leave it like that. I can't have decimals. So I just put it in there to see the math, because I didn't want to think all that much. And therefore, instead of 134.3, I'm going to round up. Remember, these are people. So I'll say 135. My N1 is the 1,343. 3. I can do the same trick for x2. So I have 232 times 5%. That gives me 11.6, but remember, I don't want the decimal, so I'm going to change that to 12. My N2 is the 232. My test is to see if one is greater than the other, if x1 in 1 combo is greater than x2 in 2. There we go. And I'm going to go ahead and draw it. Okay, here we go. Our p-value is 0.0092, but our alpha was 0.05. Our p-value is less than our alpha, and therefore we reject H0. Our claim was not an H0, our claim was an HA. And therefore we have enough evidence to support our claim. The proportion of whites iPhone owners is greater than the proportion of African American iPhone owners. All right, that's it for this lesson. Until next time, be seeing you.